In the world of mathematics, many strange results are possible when we change the rules. But there is one rule that most of us have been warned not to break. Don't divide by 0. How can the simple combination of an everyday number and a basic operation cause such problems? When we start dividing by smaller and smaller numbers, it gives you bigger and bigger answers. 10 divided by 2 is 5, by 1 is 10, by 1 half is 20, and by keep on doing 1 millionth is 10 million, and so on. So it seems like if you divide by numbers that keep decreases all the way down to 0, the answer will grow to the largest thing possible. Then it is not the answer to 10 divided by 0, actually infinity. That may sound probable, but we all really know is that if we divide 10 by a number that tends towards 0, the answer tends towards infinity. And this is not the right thing to say 10 divided by 0 is equal to infinity. Well, take a closer look of what is meant by division. 8 divided by 2 could mean how many times must we add 2 together to make 8, or 2 times what equals to 8. Dividing by a number is essentially the reverse of multiplying by it in the following way. If we multiply any number by a given number x, we can know if there is a new number we can multiply by afterwards to get back where we started. If there is, the new number is called the multiplicative inverse of x. For example, if you multiply 7 by 3 to get 21, you can then multiply by 1 by 3 to get back to 7. So the multiplicative inverse of 3 is 1 by 3 and multiplicative inverse of 10 is 1 by 10. As you notice here, the product of any number and its multiplicative inverse is always 1. If we want to divide by 0, we need to find its multiplicative inverse, which should be 1 over 0. This would have to be a such number that multiplying it by 0 would give 1. But because anything multiplied by 0 is still 0, such a number is impossible. So 0 has no multiplicative inverse. Is this really settle things? Though after all, mathematicians have broken rules before. For example, for a long time, there was no such thing as taking the square root of negative numbers, but then mathematicians defined the square root of negative 1 is as a new number called I, opening up of a whole new mathematical world of complex numbers. So if they can do that, couldn't we just make up a new rule? Say that the symbol infinity means 1 over 0 and see what happens. Let's try it. Imagine that we do not know anything about infinity. By seeing the definition of a multiplicative inverse, 0 times infinity must be equal to 1. That means 0 times infinity plus 0 times infinity should be equal to 2. Now, by the distributive property under addition, the left side of the equation can be rearranged to 0 plus 0 times infinity. And since 0 plus 0 is definitely 0, that reduces to 0 times infinity. Unfortunately, we have already defined this as equal to 1, while the other side of the equation is still telling us it's equal to 2. So 1 equals to 2. Oddly enough, that is not necessarily wrong. It's just not true our normal world of numbers. There is still a way it could be mathematically valid if 1, 2 and every other number were equal to 0, but having infinity equal to 0 is ultimately not all useful to mathematicians or anyone else. So dividing by 0 in the most obvious way doesn't work out so great.